Hi, I'm really happy to be here to talk about the Amazon EKS strategy, roadmap, and vision. I'm Alan Name, and I'm a product manager on the Amazon EKS team. I'm joined today by Anu Dupe, VP of Engineering at Salesforce. Our agenda consists of 4 parts. I'm going to start by reviewing the guiding principles that the EKS team has used to drive our product strategy. Then, I'll provide you with a recap of some of the key product launches we announced in 2021. I'll then hand it off to Anu to talk about how Salesforce used EKS to build an internal microservices platform. Finally, I'll close our session by walking you through the EKS roadmap and vision. So, without any further ado, let's get started. Amazon EKS provides the flexibility of Kubernetes with the security and resiliency of being an AWS managed service. Here are a few attributes that you have come to appreciate about Amazon EKS. First, we do not modify open source Kubernetes. EKS is fully upstream, certified, conformant Kubernetes. We even backport security fixes to ensure we are consistent with open source. Next, we support upstream versions for a longer period of time. We support up to 4 versions of Kubernetes, which gives you sufficient time to roll out upgrades. As part of this, we even backport patches, fixes, and upgrades to Kubernetes versions, even the ones that the community may not currently support. We provide a managed Kubernetes experience where we do a lot of work to select the right Kubernetes version, validate dependencies to provide the security, stability, and operational excellence that you rely on us to deliver. Last, we want to reduce the complexity of Kubernetes operations. What EKS provides is a managed experience with Kubernetes that enables application portability across Kubernetes environments. EKS is used in every industry around the world, including finance, gaming, retail, social media, transportation, healthcare, and public sector. We have lots of customers in every country that use Amazon EKS to deliver value for their business. Now, let's talk about the tenets that we decided to anchor on when we created Amazon EKS. We wanted our product to support production workloads across every customer segment, from startups to Global 2000, in every industry. We consider security as job zero. Our top priority is to deliver to our customers a highly secure and stable service. In EKS, we've created millions of clusters. We've handled hundreds of thousands of cluster upgrades. And at the scale we operate, change management is extremely critical, such that any change that we roll out is validated to ensure we don't introduce any changes for your running applications. As an example, for a number of CVEs, the EKS team was able to roll out patches across our fleet without customer involvement, many of them for CVEs before they're even publicly disclosed. For our engineering team, we take a lot of pride in security and operational excellence. On the product team, we consider security and reliability as 2 of our most important product features. We also want to be good community citizens and stick with a native upstream experience. We provide a seamless integration with AWS Cloud Services so that we're reducing the undifferentiated heavy lifting for you. And we're committed to open source and want to make sure you have access to the breadth and depth of open source community projects so that you can innovate quickly and take advantage of all the goodness coming from the upstream community. Our vision is for you to have everything you need to build and run complete clusters in a single place. You can create a cluster using a single command with all the compute resources, tools, and control that you need to run your applications. You get ongoing information like logs, performance data, health alerts that give you complete control and peace of mind. So, let's recap some of our notable product launches in 2021. You now have more deployment options for Amazon EKS, ranging from EKS on AWS to Outposts, local zones, to deployments on your self-managed compute with EKS Anywhere, to EKS Distro, where you can use your preferred tooling or favorite partner solution. In 2021, we launched EKS Anywhere. With EKS Anywhere, you can create and operate EKS distro-based clusters on premises. From a deployment footprint standpoint, you can get started with a minimum of 5 to 6 nodes for a highly available control plane and worker nodes. We provide an opinionated set of cluster creation and lifecycle management tools on top of EKS Distro. Let's talk about what this includes. We include a node operating system. We bundle in BottleRocket and also support Ubuntu. We also include a bundle of EKS Cuddle as a command line interface to provide operational consistency with EKS on AWS. We include Cilium for pod policy and CNI. We support authentication through any OIDC compliant identity provider. We also include an EKS Anywhere Flux v2 for GitOps tooling. You will also have the option to connect your EKS Anywhere clusters back to the EKS console for visibility into cluster deployments across all your Kubernetes environments. EKS Anywhere is an opinionated bundle of open source software to deploy and manage Kubernetes clusters on premises, and it's open source. In addition, you can purchase enterprise support for any part of the EKS Anywhere stack that we bundle in. AWS will be your single point of contact for any issues that you run into with EKS Anywhere. We extended the EKS console to enable you to attach any conformant Kubernetes cluster to the console and surface Kubernetes metadata from a single location. In the future, any EKS managed operation that uses the Kubernetes API will be available on any cluster you connect back to EKS. One of the first bottlenecks you will hit when running Kubernetes at scale is networking. And to be clear, this is not Kubernetes dual stack support, which doesn't help with IPv4 exhaustion. We will be launching support for IPv6 only pods. With this feature, you can give each pod a globally unique IPv6 address instead of a VPC unique IPv4 address, allowing you to scale far beyond the IP address limitations you may have in existing IPv4 based VPCs. Even with IPv6 only pods, EKS will configure networking so pods can still communicate with IPv4 endpoints outside the cluster, allowing you to take advantage of IPv6 benefits without waiting on the rest of your organization. We will be launching this in the coming months, so stay tuned. While we work on ensuring the Kubernetes control plane scales for all your use cases, you also need to ensure the compute connected to your cluster is scaled to your needs. We will continue to support the cluster autoscaler, but for really big clusters, or those that we need scale very fast or very large, we think an alternate approach is worth considering. Check out Carpenter on GitHub. Carpenter is an open source, flexible, and high performance Kubernetes cluster autoscaler. We've been listening to all your feedback, and the project has evolved to meet your use cases. The project is ready for you to use with your production workloads. Customers who deploy applications with Kubernetes are looking to provision supporting AWS services, such as databases, message queues, and object stores. While AWS provides a set of managed services to provide resources for these apps, provisioning and integrating them with Kubernetes is complex and time-consuming, especially for clusters that have a very short lifetime. AWS Controllers for Kubernetes is an open source project that lets you define and consume AWS services and resources directly from a Kubernetes cluster. It gives you a unified way to manage the lifetime of your application and all of its dependencies. We've made a ton of progress since the last time we spoke, and our first controller for SageMaker has GA'd and reached the 1.0 milestone earlier this month. In the coming weeks, we'll be launching GA for additional services such as Elasticache. We're also in preview with S3, DynamoDB, ECR, Amazon MQ, RDS, just to name a few. CDK8s for Kubernetes is also now GA. CDK8s is an open source software development framework for defining Kubernetes applications using familiar programming languages, such as TypeScript, Python, Java, and .NET. The output is standard Kubernetes manifests, which can be applied to any Kubernetes cluster. Our goal with EKS has been to provide you the best experience with running Kubernetes. When we first started, we launched the EKS control plane. We managed a highly available, secure, and resilient control plane for our customers. Later, we added managed node groups, EKS, where we extended the EKS API to manage the Kubernetes worker nodes on EC2 instances in the customer's VPCs. With EKS on Fargate, we provided a serverless compute option for EKS. This laid the groundwork to provide fully managed Kubernetes clusters, where we take care of everything from security patches to version upgrades to monitoring and alerting. And 2021 was a really busy year for us. We made several feature releases that got us closer to this vision on eliminating the undifferentiated heavy lifting for our customers. We intend to continue on this journey to provide a fully managed experience for the entire cluster lifecycle. We announced EKS add-ons in December 2020 and have expanded support to include the core EKS networking add-ons. Over the next year, other common add-ons for observability, scaling, management, and security will be added. And we're not done yet. You will see a lot more coming from EKS in 2022. At this point, I'd like to invite Anu to talk about how Salesforce used EKS to build an internal microservices platform.
Thanks, Alan. Hello, everyone. I'm Anubhav Dut, VP of Engineering at Salesforce. I'm really excited to be here to take you on a journey into Hyperforce. I will show you how we used EKS to build a microservices platform that increased agility, enhanced trust and security, while reducing operational cost and complexity at Salesforce. I'll lay out the background and then go deep in the technical architecture. At the end, I hope you can take away patterns and practices to apply in your own organization. With that, let me introduce you to Salesforce. Salesforce is a pioneer and leader in enterprise cloud computing with a focus on CRM. We are the fastest growing enterprise software company in the world with a revenue of $21.25 billion in FY21. Salesforce has reached number one in several categories according to IDC in April 21. We are number one in CRM, number one in sales, number one in service, and number one in marketing. We are thrilled with the success our platform and our Trailblazer community have achieved over the years. But what we are particularly proud of is that we are also a leader in innovation, a leader in philanthropy with our 1-1-1 model, and a leader in culture. With that introduction, let's look at what is Hyperforce. Hyperforce is an exciting development in Salesforce technology representing a complete re-architecture of Salesforce platform, designed to deliver an even more powerful and scalable platform than we have today. Hyperforce will support the growth and success of Salesforce global customer base and empower Salesforce customers to securely deploy Salesforce apps and services from anywhere while using the scale and agility of the public cloud. Hyperforce is going to allow us to accelerate delivery of Salesforce services to different customers with different needs in different parts of the world. It enables us to securely and reliably deliver the Salesforce Customer 360, including Sales Cloud, Service Cloud, Marketing Cloud, Commerce Cloud, Industries, and much more on major public clouds. Today in our talk, we are going to focus on the layer called Hyperforce Foundational Services. These are internal services that address a set of common needs for all Salesforce teams as a foundation. The customers are other internal teams that are building Hyperforce. Each of the public cloud substrates have their own set of functions. By providing these foundational services, we make it easy for Salesforce teams to build Hyperforce on top of public cloud substrates, meet Salesforce requirements, and integrate with Salesforce infrastructure. So let's dive into one of these foundational services, which is our compute platform. While building Hyperforce, we saw the need for a compute platform. A majority of teams that are building on Hyperforce chose to use Kubernetes for all the advantages it provides. And as you look around in your own organization, you might see the same pattern. But not all teams are experts at running Kubernetes clusters. Our teams also need to be ready for a multi-substrate platform to extend Hyperforce in the future, even as we focus on AWS in our talk today. Also, Salesforce has a number of infrastructure services, such as security, monitoring, and connectivity. All Hyperforce services need to integrate with these in a Kubernetes native way, and these integrations need to be managed. Also, after you deploy your Kubernetes apps, there are a lot of day two needs, such as scaling the applications and the underlying infrastructure, patching and upgrading the fleet, ensuring availability of these applications, having visibility for operations, and managing cost to serve. To solve all of these needs, we created an internal platform for all of our teams to use in Hyperforce called the Hyperforce Kubernetes Platform, or HKP. We also decided to use EKS on AWS as a foundation. This was an easy decision for us. Our team has managed Kubernetes on the last 6 years on our own data centers, which I like to say, doing Kubernetes the hard way. We gave a talk at KubeCon EU last year that describes our journey. So when it came to AWS, it was a no-brainer for us to use EKS. We rely on EKS to do the heavy lifting of Kubernetes control plane management as well as etcd, and integrations into AWS infrastructure. EKS also gives us the full power of Kubernetes API that is open source compatible, and that's a big deal for us because there are lots of complex distributed applications at Salesforce that need this. So if you compare all the options available, this was the best suited for our needs. So to recap, HKP provides a multi-substrate and completely managed Kubernetes platform integrated with Salesforce infrastructure. We build on top of cloud Kubernetes engines like EKS. Our mission is to empower service owners to focus on their unique value of their service without having to focus on infrastructure. This increases developer agility while decreasing operational cost and complexity. Very simply, we let service owners focus on their business value while we focus on Kubernetes infrastructure. So let's see how HKP works at a high level. Customers, which are service owners at other teams at Salesforce, they provide us their container. And we provide them a Kubernetes namespace as a service model. I'll go into more details in a later slide. Just think of namespace as a partition of the cluster. The services in that namespace run alongside services from other teams on that shared cluster. We as HKP inject Salesforce infrastructure and meet other requirements by using daemon sets, sidecars, and controllers. For folks who are familiar with Kubernetes, they would know these are ways to extend your Kubernetes application and cluster functionality. So how does this help Salesforce? First and foremost, Salesforce teams get much higher agility since they can focus on their application and all infrastructure needs are met by HKP. It also reduces the ongoing operational overhead, helping them innovate faster. Some teams have said it helped accelerate their go-to-market by a few months by relying on our platform. HKP also manages all the Salesforce infrastructure integrations into Kubernetes, including certifying a new release, safe rollouts, and continuous monitoring. HKP provides 24/7 support for all clusters and integrations. Maintaining trust is our number one value at Salesforce. We help maintain security and trust by running the most up-to-date, secure, and patched version of Kubernetes and Salesforce infrastructure integrations at Hyperforce. By consolidating compute in a single platform, we can do cost optimizations that provide the same or higher availability at much lower cost to serve. For example, we can share the auto-scaling buffer capacity across a bunch of teams. Also, larger shared clusters are much more resilient for a few machine failures. And finally, by solving problems in a central team, we avoid dedicated Kubernetes cluster management resources in every Scrum team. Based on an internal survey, it was roughly around 1.5 engineers per service team. And given there are hundreds of service teams at Salesforce, that's a big deal. So with that, let's dive into the architecture. An engineer on our team, HKP, uses Terraform and Spinnaker to bring up Kubernetes clusters and integrations. Our customers are service owners at Salesforce. They write their service code, and that gets packaged up into Docker containers. Next, they describe their application using Helm charts, which are basically application packaging format for Kubernetes apps. This gets deployed into the Kubernetes clusters, also using Spinnaker. HKP adds various enhancements on the Kubernetes clusters as Kubernetes-based services themselves. These include services for security isolation, recycling nodes for patching, validating all the integrations, getting visibility for operations, and managing cost to serve. We also add multi-tenancy configuration on top of these clusters to enable them to be shared across multiple service teams, and that's what we're going to look into next. So our customers are various teams at Salesforce who are building Hyperforce. We run a number of clusters that are shared across all of these teams. Their workloads, such as Kubernetes deployments, run on one or more namespaces on these shared clusters. Kubernetes namespaces are basically a way to share a cluster across multiple workloads from different teams safely. We also leverage AWS best practices, which is to give an AWS account to each of those service teams. We use Kubernetes role-based access control, or RBAC, to limit access from teams to their namespaces. EKS makes it easy for us to achieve that by using the EKS auth config map. Teams will have access to their own namespaces. Let's see in action. Team A will have access to namespace 1 and 2 on that shared cluster, but they won't have access to deployments in namespace 3, which is owned by tenant Team B. The workloads themselves are also locked down. We want to use IAM permissions to limit access to resources in AWS, even though these workloads run on the same shared cluster. We rely on EKS IAM role for Kubernetes service account feature to associate tenants' IAM roles with their workloads running on the shared cluster. Teams can then use IAM permissions to limit access to their cloud resources outside the cluster to only their workloads, even though they're running on that shared cluster. Let's see how this works. Let's say Team C creates an S3 bucket. They can now use IAM permissions to limit access to only their deployments running on that shared cluster. If another team tries to access those S3 resources, even though they run on the same shared cluster, they would not be able to. This is ability to use the best of Kubernetes and AWS working together. Next, we will look at how services communicate with each other. Hyperforce is built on hardened internal services with authentication, authorization, and encryption at every step using programmatic security. We use service mesh for services to talk to each other. Policies are enforced using a sidecar model. Sidecars are basically utility containers that run next to the main application container. These sidecars use the technology called Envoy, which attaches themselves to the main application service and intercept all inbound and outbound traffic. Let's see how this works by looking at the traffic. So the dark blue arrows shows the traffic coming from left to right. So let's follow that. Traffic coming in from outside hits the AWS load balancer and then comes to our ingress gateway layer, which is also based on Envoy. From there, the application enters our service mesh. We achieve authentication by distributing strong identity to each of these applications that lets them prove who they are. We use Open Policy Agent, or OPA, which is another open source project, to distribute authorization policies which limit who can talk to whom, and that is enforced by the sidecar. The sidecar also enforces encryption between service calls. To manage all of these sidecar envoys, we use Istio for control plane. And Salesforce is very big contributor to both Istio and Envoy. So within our service owners' Helm charts, we want to make sure they use the guidelines for security, isolation, and best practices that we lay out. But to ensure that, we use Open Policy Agent to enforce these. And we enforce policies twice. We do it once in build time to give early feedback to service owners. But to be absolutely sure, we also enforce runtime checks inside the cluster. This makes us easy to operate these clusters safely and securely, and also reduces our ongoing operational overhead because we can keep service owners away from the rough edges of the Kubernetes Service API. From our experience of running Kubernetes in the last 6 years, we learned an early lesson. It's easy to know what's going on in your cluster right now, but it's hard to know what happened in the past. Both cluster operators like us and our customer service owners would love to know what happened which caused a problem in their application, say 6 hours or 2 days ago. Wouldn't it be great if you had a tool that let you go back in time and see what happened? That's exactly what we did. So we created a tool called Sloop that we open sourced. It makes it easy for you to visualize what's happening on your cluster on a timeline. Let's look at a snapshot of how it works. This is a snapshot that shows you Kubernetes events and payloads on a timeline. So changes become obvious, as you can see, and we can quickly drill down on what exactly changed. Numerous times we have been able to use Sloop to quickly troubleshoot this one line change in the Helm chart, which was the root cause of a problem, within minutes. Apart from Sloop, we also open sourced another project called Sidecar Injection. When we started on our Hyperforce journey, we realized we wanted to inject sidecars. And a lot of teams were writing the same boilerplate code to inject sidecars. We decided to make a framework out of it such that teams don't need to write any code. They can just write config, and that injects the sidecars on the fly. This is called Mutatic Admission Controllers, which is a pattern in Kubernetes, and we made a framework out of it that we open sourced. We also gave numerous talks over the years at KubeCon and other conferences. We also wrote a blog that describes our Hyperforce journey. So to summarize, what are the key takeaways? First, building a central Kubernetes platform has helped Salesforce achieve agility, maintain trust and security, and make it easy for teams to focus on their business value. The Hyperforce Kubernetes platform adds Salesforce integrations in a Kubernetes native way on multi-tenant clusters that are fully managed by a central team. EKS on AWS is a great way to leverage the best of AWS and Kubernetes open source. Thank you. Back over to you, Alan.
Thanks, Anu. Let's talk about the EKS roadmap and vision. When we think about the roadmap, we typically break things up into 4 buckets: security and reliability, management and observability, performance and scale, and consistency. We're going to cover each of these areas, including what we've launched and what's coming over the next year. For security, it's the area we on the product team spend the most time on, and the feature gets prioritized over everything else. For reliability, with EKS, when you create the cluster, you get an API endpoint. That endpoint is going to respond whether you're running 10 worker nodes or 1,000 worker nodes. One of the biggest benefits of running EKS on AWS is that you can take advantage of all of the AWS innovations in infrastructure, whether it's running etcd on the latest EBS volumes or the API server running on the latest EC2 instances. This also translates to improved performance for existing clusters without having to do anything. Let's talk about some of the features we've launched and what's coming soon. We launched support for taints and parallel node upgrades. Taints let you isolate workloads within a cluster. Parallel upgrades let you upgrade node groups in a faster amount of time. We also launched BottleRocket in managed node groups. Most EKS customers today deploy their applications on worker nodes backed by an operating system that's designed for a variety of use cases. AWS launched BottleRocket, a minimal Linux-based open source operating system that is purpose-built and optimized to run containers. When combined, EKS managed node groups and BottleRocket give you a simple way to provision and manage compute capacity using the latest best practices for running containers in production. BottleRocket is now included as a built-in AMI choice for managed node groups, enabling you to provision container-optimized worker nodes with a single click. Amazon GuardDuty is a threat detection service that continuously monitors for malicious activity and unauthorized behavior to help you protect your AWS accounts. Amazon GuardDuty for Kubernetes audit logs is now GA. A couple of other areas worth noting involve cluster access management. Cluster access management is done today through AWS Authentication Config Map. We are working to move that authentication into the EKS API to make it easier to manage authentication through infrastructure as code tools like CloudFormation and Terraform. Much of our roadmap here is to provide automated lifecycle operations to make managing both a single cluster and many clusters easier. For observability, it's about both the control plane and user applications running in the cluster. How do we make it easier for you to ingest and understand insights so that you can improve performance, reduce costs, and minimize the time it takes to troubleshoot issues? We launched EKS Connector to enable you to connect any conformant Kubernetes cluster to the EKS console by simply installing an agent on the cluster. This enables you to now visualize all your clusters in a single place using the EKS console. We also launched additional EKS add-ons such as Core DNS, kubeproxy earlier this year. We also have a roadmap of additional add-ons that we are coming with, such as support for OpenTelemetry, CSI drivers, load balancer controllers, and metric server. The work we're doing for add-ons is really to help make it easier for you to manage the lifecycle of your Kubernetes clusters. Some of the other things on the roadmap include integrated GitOps with Flux. We're going to make it possible to install Flux directly using an EKS add-on. This will simplify how you do change management across multiple clusters. And for observability today, we exposed Prometheus metrics for the control plane, but you still have to do the work of ingesting those metrics and analyzing them. We want to make that easier for you so that you can just go to the EKS console and see what's happening with your control plane. We're also investing in providing you with cost allocation features in EKS so that you have better visibility into resource usage across teams, namespaces, pods for chargeback. After security and reliability, performance and scale are the most important sets of features. It's really about providing you with features to make it easier for you to scale your applications dynamically and make the right trade-offs for availability versus cost. One of the top feature requests since we launched EKS is increased pod density. We work closely with the EC2 team to build a container-optimized VPC feature where you can attach prefixes to IP address blocks to nodes rather than individual ones, and we added support in the CNI plugin. You no longer have to worry about IP address as a constraint for achieving full efficiency on your worker nodes. You can now manually scale managed node groups from 0 and back up. We're also working on contributing upstream to Cluster Autoscaler to make it automatically scale up and down. Last but not least is consistency. It's about giving you the same consistent supported experience anywhere you run EKS. Also, it's about the ability to run Kubernetes in different environments without having to make changes to your apps. We talked about these features earlier, including EKS Anywhere, CDKs, and ACK. For EKS Anywhere, we're working on extending it to support bare metal deployments and also GPUs. For multi-cluster, one of the challenges we hear from you is how to improve how services discover each other, regardless where they live. We're working on implementing a controller that uses the upstream multi-services API along with CloudMap as the backing layer that gives you an easy way to do service discovery across clusters. And finally, the EMR team is looking at adding more frameworks on EKS in addition to Spark, such as Plink and Presto. I'm going to wrap up today's talk with a few words about our public roadmap. We encourage you to visit our public roadmap regularly. You can see what others are saying, upvote, and comment on things you'd like to see, or submit your own ideas if you think we can do better. Much of what you saw today comes from the feedback that you provided us on the public roadmap. So go check it out. If you see a feature you like, +1 it. This is how we prioritize the features that we work on. So with that, thank you.